Okay, so now instead of looking at bingo chips, let's take a look at isotopes. So isotopes are when we have elements that have the same number of protons but different number of neutrons, so a different flavor of the same element. In terms of their physical properties versus chemical properties, they have the same chemical properties, but they have different physical properties such as density, rate of diffusion. Okay? Here are two examples. So we have bromine 79, bromine 81. We talked about what that means a few videos back, but again, what we can do is we can take a look and we can talk about the probability of picking up one isotope versus picking up the other isotope. So again, I have 3 isotopes in that pile of isotopes of each type, and so the probability of picking up a bromine 79 is 3 out of 6, or 50%, and bromine 81 is 3 out of 6, or 50%. Now we can do exactly what we did with the bingo chips, where instead of mapping my objects, I can graph based on mass. So again, here I have a 50% chance of picking up something with a mass of 79 and a 50% chance of picking up something with a mass of 81. Based on that information, I can then calculate my average mass. Remember, average mass is where we take the probabilities and multiply it by their respective masses. So we're taking our 50% probability, multiplying it by 79, taking our 50% probability, multiplying by 81, and that'll give us an average mass of 80. Now careful, when you're typing this into your calculator, don't forget that 50% really is 0.5, so you need to convert your percentages into decimals. Okay? Now we can do that for all types of elements. Let's take, for example, carbon. Carbon has 3 isotopes that are relatively stable: carbon 12, carbon 13, and carbon 14. The percentages you see on your screen are the natural abundances. So if we were to take a handful of carbon, 99% of that carbon would be carbon 12. And only 0.9 and 0.1 would be carbon 13 and carbon 14. So again, we can measure the relative atomic mass, symbol AR, by multiplying our percentages, our natural abundances, by their respective masses, and we can figure out the relative atomic mass, and that's the mass that's reported on the periodic table. Okay? And so again, don't forget to either convert to percentages or divide your number by 100 at the very end.